you look for the Laplace transform of cos alpha theta. So find the Laplace transform of cos alpha theta. Cos alpha theta. So note that the Laplace transformation of cos alpha theta will still give you the integral of 0 to infinity. You have your exponential x minus st f of t times t. But our f of t will give you cos alpha theta. Cos alpha theta. So all you need to do, you just put the value of your f of t here in the formula in this equation. So we're going to have your Laplace transformation of cos alpha theta will give you Laplace transformation of the integral form of 0 to infinity. Then you have your exponential raised to power minus st. Then your f of t now, will now give you cos alpha theta times your dt, because your f of t will give you cos alpha theta. So now you have the equation in this form. So having the equation in this form, what will you do? You also make use of integration by parts. So now this is a function multiplying another function. So if you have the function multiplying another function, all you need to do in order to integrate it, you will make use of integration by parts. And integration by parts is just u v minus what? Integral of v du. So this integration by parts. You have integration by parts. So now I will take something now. I will take my u equal to a value and also take my v to give you a value. So now my u, I will take my u to give you a value. So now this integration by parts, this is a formula. So I select my u equal to what? Exponential minus st. I have my exponential minus st. So what do I do? I'm going to differentiate u with respect to what? T. So now I have my du over the t will give you this one. Now it will now be this. It will now be minus x. Your x now is a constant. So it will now be your constant is carrying a negative sign. It will now be the negative sign times your constant. Then you multiply it by the exponential to the same power, which is minus st. So this is du over the t will give you this. So if the t now cross over, you have your du will give you minus x raised to the power of minus x times exponential raised to the power of xt. This times t, you have the t. So the t multiplied by x minus x times exponential minus xt will give you what? Du. So it's like this, multiply this, you have du is equal to what? X minus x times exponential minus st times dt. So this is what I'm going to get now. So du will give you minus x exponential minus st dt. So now I have my du equal to this. So now the next one now will be, I say let v equal to cos what? Alpha t times what? dt. Let my v give you cos alpha t times dt. So now I'm going to integrate this. So if I'm integrating this, the v, it will give you v and it will still give you integral of cos 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 alpha t dt, because the integral of the t will also integrate this, it will affect this. So the integral form will affect both sides, meaning that you will integrate this and you will also integrate what? Cos alpha t times what? Dt. So now your integral form of the v, which means the integration of the v will give you v. So now it will now give you equal to, now if you integrate this cos alpha t, it will give you, this alpha is like a value, it's like a value, it will be like, it will be 1 2 3, a value. So you now have, let's say you have sine, you have sine, sorry, you have 1 over alpha sine what? Alpha t. So the integral form will cancel, will eliminate the t. So this one now is that this one is not 1, is a value. So let's say if I'm having 1, so there's no point me saying 1 over 1, because 1 over 1 will give you 1. So let's assume that this alpha is more than 1. So it will now be like 1 over, let's say it's 2. It will now be 1 over 2. So that's why I'm using this alpha, because I can't say this one is 1. So if I say it's 1, meaning that there's no point saying 1 over this. So it's assumed that it's more than 1. So you have 1 over alpha sine alpha t. So by the time you do your integration, everything now will give you v. So finally your thing will give you 1 over alpha sine alpha t. You understand? So now all these things, all these values you have, I'm going to put it in the integration by parts. And our integration by parts, all know is uv minus what? Integral of what? v du. This is integration by parts. So all these values that is here, I'm going to put them here. Where is my u? I have my u here. My u here is exponential minus st, then times my v. Where is my v? My v is this. I have times 1 over alpha sine alpha t and alpha t. Then minus, then I have my integral. My integral v. Where is my v? My v is this one. 1 over alpha sine alpha t. Then multiply by du. My du is this. My du is equal to minus x times exponential minus st times t. I have times minus x exponential minus st times what? dt. This one now is your du, and this d now is this one, 1 over alpha sine alpha t. So now I have used integration, this integration by parts. So I have something like this. So finally, you can now say, okay, this is exponential minus st into 1 over alpha sine alpha t. Then this one now, this 1 times minus x will give you, this is minus here, you have your minus, then your integral. This integral now is your integration sign. Then you have minus x over what? Alpha. How do I get this minus x over alpha? This is 1. 1 times minus x will give you minus x over this alpha. Then you have your sine alpha t. Then you have your e exponential minus st times what? dt. Times your dt. You understand? Times dt. So x minus x over alpha is constant. So you will bring it out from the integration sign. So you're going to have exponential minus st into 1 over alpha sine alpha t. Then, if you bring this one out, it will now be, this is minus, you have minus x over alpha, then you have your, this integral, then you have your sine alpha t multiplied by the exponential minus st times what? The t. Understand? So this is your constant. You take it out from the integration sign. So you have the integration, the integral of sine alpha t multiplied by exponential minus st times this here dt. So now we have this equation. We will know that minus times minus will give you a plus. So this automatically will change to what? Plus. Are we there? So once we do that, we will now include our limit. That's where's our limit? Our limit to start from 0 to what? Infinity. Start from 0 to what? Infinity. So you start from 0 to infinity. So finally, I have my this exponential minus st multiplied by 1 over alpha sine alpha t minus, okay, minus minus is plus. If you change to plus, no longer minus again, you now change to plus x over alpha. Then you have the integral of sine alpha t multiplied by the exponential minus st times what? Dt. Are we there? Times dt. So now I want to include my limits. Including my limits. I want to include my limits. So I have my exponential minus st into 1 over alpha sine alpha t. So let's say I will write it this way to include my limit from 0 to what? Infinity. Then I have plus x over alpha. Then this is my integration sign. This is my integration sign. I have my integration sign. Still the limits 0 to what? Infinity. So I have my sine alpha t exponential minus st dt. So this is what I'm going to get. Now, what do I do? I need to evaluate this, taking my upper limit minus lower limit. And my upper limit is my infinity. Lower limit is what? 0. So I will now take it as this. I start with the infinity. I have exponential minus x. Then our t is infinity. Infinity multiplied by 1 over alpha sine alpha t. Are we get alpha t? So now I have this alpha t, then minus the lower limit. Because this one is the upper limit. Now this my t is here. This my t now is my infinity. Is my infinity. I have my infinity here. This t is the infinity. It's included here. I have my infinity minus this. I will still write this exponential. Exponential minus s times my t is 0. Because this is the lower limit. So my lower limit is 0. Then multiply by 1 over alpha times sine what? Alpha times what? T is what? 0. Are we there? T is 0. Then plus, this is plus x over alpha. Then I'll include my integration sign. So the integral sign, which is 0 to infinity, Then I have my sine alpha t exponential minus st dt. So this one here, the first one is the upper limit. The upper limit, and this one is the lower limit. So the upper limit is our infinity. The lower limit is our zero. So the upper limit minus the lower limit. This now is this. I'm evaluating this. So I now take upper limit, the whole of this. Then I now anywhere I see t, I put infinity for upper limit. Then I have this minus x times infinity 1 over times 1 over alpha sine alpha times t. Where is my t? My t is infinity. This is my infinity. Minus bracket. I have the next one now will be the lower limit, which is your exponential raised to the power of x minus x times what? T, which is 0. Then times 1 over alpha times sine alpha times t. The t now in the lower limit is 0. So you have 0. So like upper limit minus lower limit. So know that, just have this at the back of your mind. Know that if you have exponential raised to the power of infinity, automatically is 0. Is 0. So that 0 times this now give you 0. So that is 0 minus, then we'll move to the lower limit. The lower limit now, minus x times 0 give you 0. 0 times minus will give you 0. It's like exponential raised to the power of 0. And exponential raised to the power of 0 will give you what? 1. You understand? So times 1 over what? Alpha sine alpha times 0 will give you what? 0. Know that sine 0 will give you what? 0. Sine 0 will give you 0. So 0 times 1 here will give you 0. So finally, both your upper limit and the lower limit after the evaluation will give you 0. So you have 0 from the upper limit, 0 from the lower limit. Are we there? Say you have 0 plus this x over alpha. Then you have the integral sine 0 to infinity. They have sine alpha theta exponential minus st dt. So this one I'll give you this plus upper limit is 0, lower limit is 0, plus our s over alpha integral of 0 to infinity. They have sine alpha t exponential minus st dt. So it's like 0 minus 0 will give you 0. So 0 plus x over alpha multiplied by the integral form of 0 to infinity sine alpha t multiplied by exponential raised to the power of minus st dt will give you, finally, it will still give you x over alpha multiplied by the integral form of 0 to infinity sine alpha t multiplied by exponential minus st dt. So this is what they're going to get now. They're going to get it this way. So this one now is your Laplace transformation now. This one I'm going to get it this way now. This is what I'm going to get. Now, you're going to have this x over this, which means it will now give you Laplace transformation of cos what? Alpha t. It will give you this. It will give you x over this over times the integral form of 0 to infinity sine alpha t multiplied by exponential minus st dt. Now, you have gotten this. Please just know that this is the same thing as this is the same as Laplace transform of sine alpha t. This will give you still the same thing as Laplace transform of what? Sine alpha t. But we'll come to that. But let's just do this one now. Let us see that see this, I'm going to write it this way. I'll still write my Laplace transform of cos alpha t as this. I'll write it here. Then to this point, I'm going to integrate again. I'm going to integrate this one again using integration by parts. Do the second integration. And how do I integrate it? I'll still integrate it using integration by parts, because if you look at this now, I'm still having two functions: exponential raised to power minus st and sine alpha t. So I have my Laplace transform of cos alpha t will give you x over alpha, then multiply by the integral form of 0 to infinity. Then I have sine alpha t multiplied by exponential minus st times t. So it's still the same thing as integral of e raised to power minus xt, then sine what? Alpha t dt. So it's still the same thing. Or should I say the same thing as x over alpha integral 0 to infinity? Then I have my e raised to power minus xt sine alpha t t. So what I just did here, this one I bring it here, this one I move it this way. So you see the same thing. So now this one I give it this. So now I want to integrate this. I will leave this constant x over alpha. I will leave this constant x over alpha. Then integrate this. I want to integrate this one 0 to infinity. I need to integrate this exponential minus xt sine alpha t dt the second time, because I did the first integration now using a integration by parts. So I want to integrate it again the second time using integration by parts. So now I'll still take my u as e raised to power minus st. So if I differentiate my u with respect to what t, I have this one that will be the constant is minus x. It will be minus x times your exponential, still you have the same powers, minus what? St. So that the u now will give you this one. I will come over here. It will now be minus x raised to the power of minus st times what? The t. You understand? So this one now will give you, the u will give you this one now. So now the next one now is this one. So I will now take my dv equal to sine alpha what? T times what? A t. So now I'm going to take the integral form. The integral form of dv will give you v, and it will still give you the integral form of what? Sine alpha t dt. Mind you, this integral is your integration sign. It's your integration. This is integration symbol. So now, if I integrate this, I'm going to have, if you're integrating sign, you have a negative value. This sign now will change to cosine, but it will now carry a negative value. So it's not like when we integrated cos, there was no negative value. It was positive. So if you integrate cos, it will give you sine. But if you're integrating sine, it will give you a negative value. So now you're going to have minus this one now. You have alpha is a value, is constant. So you have minus 1 over alpha. Then this sign now will change to what? Cosine. Are you getting it? So you have cosine, you now have cosine alpha t. So finally, your v will give you minus 1 over alpha cos alpha t. This is your v now. So by the time you do your integration, you will have it equal to minus 1 over alpha cos alpha t. So mind you, if you integrate sign, you change cosine, but it will go with a minus sign. So now, what I'm going to do now, mind you, I'm integrating this using, I'm doing this the second time using integration by parts. So for me to solve it, I'm going to use integration by parts. That's it, u v minus integral of v du. This is integration by parts. So I'll use it now to evaluate. So now I'll come over here. I'll come over here. So I have this. Before I end up this, I will I will write this equation somewhere. From this equation, after getting my Laplace transform of cosine equals alpha t, I will use this equation to get my Laplace transform of sine alpha t. So let me solve for the Laplace transform of cos alpha t first. So once I get the value for that, I can now use this equation and this one to get the Laplace transform of sine alpha t. So now I'm going to do the integration by parts. When I do that, mind you, this our u, my u is this, my u is exponential, my u is exponential, my u is exponential minus st. I have u equal to exponential minus st. What's my v? My v is this one. So v into minus 1 over alpha cos alpha t. Then minus I have a minus integral of v. This my v is still minus 1 over alpha cos alpha t. Then times du. My du is this minus x multiplied by exponential minus s times t. I have multiplied by minus x exponential minus st times what? Times dt. So I'm going to write it here. So this, when you have this equation, this is an integration sign. So whenever I have a constant in integration sign, you bring it out from integration sign. So my constant here, 1 minus 1 over alpha and times minus what? X. So now this is minus 1 times minus x. If you look at this equation, minus 1 times minus x will give you what? X. Mind you, the minus will definitely change to plus because the minus is multiplying another minus. So minus times this minus will change to plus. So you're going to have this exponential minus st. This I'm writing it here. St into minus 1 over alpha cos alpha t minus integral. Now minus. So it will be minus integral of minus 1 times minus x will give you x over alpha, then you have cos alpha t, then you have your exponential raised to power minus st dt. So this exponential minus st times what? Dt. So you write it exponential minus st times dt. So this x over alpha is a minus sign. So this x over alpha is a constant. So you bring it out from the integration sign. So if you bring it out, you're going to have exponential minus st into minus 1 over alpha cos alpha t, then minus x over alpha multiplied by the integral of cos alpha t exponential minus st times t. We're going to have it this way. So now, once you write it this way, the next thing I will do is to include my limits. I will include my limits. That is from 0 to infinity. So I have here as exponential minus st into minus 1 over alpha cos alpha t. Then, for me to include my limit, I will present it this way. So my limit now starts from 0 to infinity. So minus 1 over, minus x over alpha. Then this is the integral form, or integration form. So your integral sign, you will now include the limit because I'm including the limits. The limits are of 0 to infinity. Then I have my cos alpha t exponential minus st times what? The t times the t. So please, this equation here, I will write it somewhere, this equation, so that I'll give it up. I'll write this equation here. Now this Laplace transformation of cos alpha t will give you x over alpha. Then integral of 0 to infinity. I have my sine x alpha t multiplied by exponential minus st dt. So this equation here, I'm writing this equation here, because I want to use it to get my sine wt after getting my Laplace transform of cos alpha t. So I will now use, once I get Laplace transform of cos alpha t, then I will use this one now to get a formula for Laplace transform of sine wt. So I will now eliminate everything here. I will cancel it, eliminate it. So when I fill it up, I'm going to have it. So now I've added my limits. So I will evaluate as usual. That is my upper limit minus lower limit. So when I do that, I'm going to have this as this exponential raised to the power of minus x. My t is infinity multiplied by minus 1 over alpha cos alpha times what? Infinity. This is infinity. T is my infinity. I'm starting with infinity. There's the upper limit. Now I now say okay, minus the lower limit. My lower limit is 0. I'll start from this exponential minus x times my t is 0. Then multiply by minus 1 over alpha. Then cos alpha times t 0, because my lower limit is 0. Now I have my minus. The next one now is minus x minus what? Minus x over alpha. X over alpha. Then you have the integration sign. Integration sign is 0 to infinity. Then I have my cos alpha t exponential minus st dt. So now, as usual, if you have exponential raised to the power of infinity, is 0. So 0 times the whole of this now times this one, this bracket, it will give you what? 0. So meaning that my upper limit is 0. So this is minus, then I move to the lower limit. I will now move to the lower limit. So now I have my lower limit bracket e raised to the power of x minus x times 0 give you e raised to the power of 0. Yeah, because 0 times minus x will give you 0. So you have exponential raised to the power of 0. Then this bracket minus 1 over what? Alpha. Cos alpha times 0 give you cos what? 0. To give you cos 0. Then I have my minus x over alpha. Then I have my integral from 0 to infinity cos alpha t exponential minus st times what? Dt. So this is my lower limit. I still have my 0 here. This is 0 minus into e raised to the power of 0 is 1. 1 times minus 1 over alpha. It will still give you minus 1 over what? Alpha. Are we there? Then cos 0. Cos 0 is what? 1. So that cos 0 is what? 1. I still have my cos 0 which is minus 1 over alpha times 1 because cos 0 is what? 1. So this one is e raised to the power of 0 is 1. So 1 multiplied by the whole of this now to still give you minus alpha times cos 0. And our cos 0 is what? 1. So alpha times which is cos 0 1. Then minus x over alpha multiplied by integral of 0 to infinity. Then I have cos alpha t exponential minus st dt. So finally, you're going to have this minus alpha times 1 give you minus into minus 1 over what? Alpha. Because minus 1 over alpha times 1 will give you minus 1 over alpha. Then minus x over x. Then you have the integral form of 0. Your integral from 0 to infinity. Then you have cos alpha t. Then multiply by the exponential minus st dt. So I'll move over to this. So all what I'm doing is derivation. So when I derive this formula, I can use it to solve questions on Laplace transform. I'll use it to solve questions on Laplace transform. So I have this. So minus times 1 is give you what? Plus. Give you plus. So you have 1 over alpha because minus times minus give you plus. Give you 1 over alpha minus x over alpha multiplied by the integral from 0 to infinity. Then I have cos alpha theta multiplied by the exponential minus st times dt times what? Dt times t. So now, what I just did now is that my Laplace transformation of what I just did is a Laplace transformation of sine alpha t multiplied by the exponential minus st times t will give you 1 over alpha minus x over alpha what? Minus x over alpha times the integral from 0 to infinity cos alpha t exponential minus st dt. So now we have gotten it this way now. That means that's why I have to write the value here. That equation that's how I'm writing it this way. Because I have that let me just use this equation. Let me use this equation. So this cos Laplace transformation of cos alpha will give you x over alpha multiplied by this integral form of this. So now, but I integrated this one now. I got this value. So now, finally, we are still working on Laplace transform of dt. So the Laplace transform of we are still on Laplace transform of cos cos alpha t. So the Laplace transform of cos alpha t will give you x over alpha. Now, the integral, I integrated this. So the integration of this now, the integration of this is equal to integral of 0 to infinity from sine wt exponential minus st dt. So if you integrate this using integration by parts, you will get this. You will get 1 over alpha minus x over alpha times the integral of 0 to infinity cos alpha t multiplied by exponential minus st times t. So when you take the integral of this one, it will give you this. So now we are still on Laplace transform of cos dt. So now I have my x multiplied by this, and the value of this, the value of, but the integral form of 0 to infinity of sine alpha t exponential minus st dt will give you 1 over alpha minus x over alpha times the integral of 0 to infinity cos alpha t exponential minus st dt. So I'm going to put it here, substitute it here, put it here. So I still have my Laplace transform of cos alpha t. Laplace transform of cos alpha t is equal to x over alpha. Then the integration of this from my result, I have 1 over alpha minus x over alpha times the integral of 0 to infinity cos alpha t times exponential minus st times t. So I have this x over alpha multiplied by 1 over alpha minus x over alpha times the integral of 0 to infinity cos alpha t exponential minus st dt. So this is what I'm going to get now. So finally, I will use this x over alpha to open up this bracket. If I open up this bracket, I'm going to have x times 1 give you x over alpha times alpha give you what? Alpha squared. So x times this x will give you minus x squared. The alpha times this alpha give you what? Alpha squared times the integral from 0 to infinity cos alpha t exponential minus st dt. So all is to still give you everything is equal to Laplace transformation of cos alpha t. Cos alpha t. So now this Laplace transform, this one, this will give you Laplace transformation of cos alpha t. This one is alone. This one. This one on the bracket, on the circle, will give you Laplace transformation of cos alpha t. So you're going to have it this way. So let me clean up this. Let me write it this way. So we're going to have it this way. Which is use a Laplace transformation. I have a Laplace transformation cos alpha theta is equal to x over alpha squared, then minus x squared over alpha squared, then multiply by this x squared over alpha squared, multiply the whole of this, and this one will give you this. You understand? Will give you Laplace transformation of cos alpha t. Yes, because 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 but but Laplace transformation of 0 to infinity cos alpha t exponential minus st dt will give you Laplace transformation of cos alpha t. So that's why I'm having this. That's why I'm having Laplace transform of cos alpha t, because this is equal to this. So now we have Laplace transformation of this cos alpha t will give you x over alpha squared, to have alpha squared. This will give you x, this is equal to x over alpha squared minus x squared over alpha squared times this Laplace transform of what? Cos alpha times 3. Now, this I have Laplace transform of cos wt, and I still have Laplace transform of cos alpha t. On my left hand side, I have Laplace transform of alpha t. That's Laplace transform of cos alpha t. So on my right hand side, I have Laplace transform of cos alpha t. So I will collect like this. This Laplace transform of cos alpha t will meet this one, that which is Laplace transform of cos alpha t. So if you collect like this, now this is minus x squared over alpha squared. It will come over here. Then it will now be Laplace transform of cos this as cos alpha t. Then this one that is minus will come over here, becomes plus x squared over alpha squared. Then have Laplace transform of cos alpha t. The same thing as the Laplace transform of here, which is cos alpha t. So cos alpha t. So everything is equal to, so it's still equal to x over alpha squared. You understand? So now I have Laplace transform of cos alpha t, and then I have another one, Laplace transform of cos alpha t. So I will factorize. If I factorize, I will have Laplace transform of cos alpha t bracket. This one now becomes what? 1 plus, if you remove Laplace transform of cos alpha t like we factorize, you will have what? Plus x squared over what? Alpha squared. So it's equal to what? X over what? Alpha squared. So if you want to get the Laplace transform of cos alpha t, what you need to do, you say divide both sides by 1 plus x squared over alpha squared. So you divide all through by 1 plus x squared over alpha squared. We do that, we're going to have this, because I'm making Laplace transform of cos alpha t the subject formula. So I'm going to have this cos alpha t into 1 plus x squared over alpha squared. So it will cancel each other. 1 plus x squared over alpha squared. So this will cancel this. So equal to x over alpha squared divided by what? 1 plus x squared over alpha squared. Because this is my x here is equal to x over alpha squared, which is your x over alpha squared. Then I'm dividing all through by 1 plus x squared, 1 plus x squared over x of 1 plus x squared over alpha squared. So now I want to look for the LCM of 1 plus x squared over alpha squared. So now I'll look for the LCM. So when I get the LCM, I look for the LCM. So the LCM of this will be 1 plus x squared over alpha squared. So let's say here 1 over 1. Let's say is what? Alpha squared. So alpha here, alpha divided by 1 to give you alpha. Alpha times 1 give you alpha squared. So the LCM is alpha squared. So alpha squared divided by 1 give you alpha squared. Alpha squared times 1 give you alpha squared. Plus alpha squared divided by 1. Alpha squared will give you 1. 1 times x squared will give you s squared. S squared. So now I have my Laplace transformation of cos alpha theta is this, which is Laplace transformation of cos alpha theta will give you this x, this is x over alpha squared, and I divide all through by this. So it will now be like s over alpha squared divided by, this is division, divided by this 1 plus s squared over alpha squared. And if you take the LCM, it will give you alpha squared plus s squared over alpha squared. So it's like this s over alpha squared is this one. Then this sign now is division sign divided by this one, the denominator. And the denominator is 1 plus s squared over alpha squared. And 1 plus s squared over alpha squared. If you take the LCM, it will give you alpha squared plus s squared over alpha squared. So you now have this s over alpha squared. Then this line is division. Divided, this is division sign. Divided by the LCM of this one, which is alpha squared plus what? S squared all over what? Alpha squared. So finally, you will change this division sign to multiplication sign. If you change it to multiplication sign, you are going to have x over alpha squared. This one will go up, this one will come down. So you now have times alpha squared all over alpha squared plus what? S squared. So this alpha squared now, we cancel this one. So finally, we are going to have x over alpha squared plus what? S squared. You understand? So finally, you now have the formula for Laplace transformation of cos alpha t. So Laplace transformation of cos alpha t will give you x over alpha squared plus x squared plus what? X squared. So this is the final answer. So this is the derivation of Laplace transformation of cos alpha t to give you x over alpha squared plus what? S squared. So now I've gotten my Laplace transformation of alpha t, which is x over alpha squared plus s squared. Now I can get my Laplace transformation of sine alpha t. So now, but we know that, but sine, but integral of 0 to infinity of sine alpha t multiplied by exponential minus s dt will give you Laplace transformation of sine what? Sine alpha t. So the whole of this now will give you Laplace transformation of sine wt. Because if you look for the Laplace transform of sine wt, and then you make use of this formula, f of x equal to integral of 0 to infinity, then this one now will be your f of t. You have the integral, you have your exponential minus st, then this one now will be your f of t. Sine alpha t will be your f of t. You now have sine alpha t times what? T. You understand? So you will still get this here now. So you still get something like this. So that means that what you are looking for is the Laplace transformation of sine wt. And the Laplace transformation now, you will now say, okay, f of t is equal to this, isn't it? So now, meaning that your Laplace transformation of what? Sine alpha theta will give you this integral from 0 to infinity. You have exponential minus st sine alpha t dt. So the reason why I'm writing this is just for you to know that this, the integral form of 0 to infinity sine alpha t times exponential minus st dt will give you Laplace transformation of sine wt. Because if you have to look for the Laplace transformation of sine wt, it will now be in this form. You complete, will now be in this form. Then finally, you also solve it. You also need to solve this integration form because you have two functions here. E exponential minus st times sine wt. You have two functions here. So for you to integrate this one, you will still make use of your integration by parts. So now we know that the whole of this now, the Laplace transformation of this will give you this. And that's the reason why I say this thing now is equal to Laplace transformation of sine wt. So from here, since I've gotten my Laplace transformation of alpha t, I can get my Laplace transform of what? Alpha t. So I will now have this. So that's why I have to write this equation. So with this equation now, since I've gotten this one now, I can get my Laplace transformation of this. So meaning that the whole of this one now is this. So I write the equation. Our Laplace transformation of cos alpha t is equal to x over alpha. That's this equation. I have integral form of 0 to infinity. I have sine alpha t exponential minus st dt. You have something like this. Now I have gotten this one now, which is this. I will put the value here. So knowing that the integral form of 0 to infinity sine alpha t exponential minus st dt will give you Laplace transformation of sine alpha t. So from here, I can now get my Laplace transform of sine wt because I've gotten my Laplace transformation of cos alpha t. So from here, but Laplace transformation of cos alpha t is equal to s over alpha squared plus s squared. You understand? So I'll put it here. And I'll say s over alpha squared plus s squared is equal to, this is alpha, Laplace transform of cos alpha t is this, s over alpha squared plus s squared is equal to x over alpha, x over alpha. Are we there? So this one now is same as Laplace transformation of sine alpha t, because the whole of this will give you Laplace transformation of sine alpha t. So now I want to get my Laplace transformation of alpha t. With this now I can get it. So how do I do it? I'll say divide both sides by x over alpha to get Laplace transform of sine alpha t. So I have Laplace transformation of sine alpha t, which means x over alpha is equal to this x over alpha squared plus 1 x squared. So divide all through by x over alpha to get Laplace transform of sine alpha t. So we do that, we now have s over alpha, then multiply by the Laplace transformation of sine alpha t. So it will give you x over s squared plus what? S squared. So divide both sides. So divide both sides by x over alpha. So this will cancel this. So that be over x over alpha. So we now have Laplace transformation. You have Laplace transformation. What do you have? We now have Laplace transformation of sine alpha theta will give you something as s over alpha squared plus s squared. You know this one we divide this one. So we now say divided by x over what? Alpha. So it's the same thing as if you change this division sign to multiplication sign, it will now be x over alpha squared plus s squared times, if you change this to multiplication sign, this one will go up, this one will come down. So now have x over what? Alpha. Well, we now have x over alpha. So that when you do that, we're going to have something like this. We do that, this one now will cancel. You now have something like this. Yeah, you're going to have this over this. Since you've gotten this, you have now be equal to x over alpha squared plus s squared times alpha over x. Yes, we're going to have it this way. So that this x will cancel this x. Cancel this x. So that you have alpha. Now have alpha. So finally, we're going to have alpha, we're going to have Laplace transformation of sine alpha t will give you alpha all over what? Alpha squared plus what? S squared. Understand? So that's the final answer, because this x will definitely cancel this x. So you have, because if you multiply it, meaning that this one will, if you are changing this sign to sign, multiplication sign, yeah, if you change it to multiplication sign, it will now be times, this one will go up, this one will come down, this one will go up, this will come down, so that this x will cancel this x. So you have alpha over x squared plus alpha squared. So this is what you are going to get. This is the formula for Laplace transformation of sine alpha t. It will be the alpha over alpha squared plus s squared. So this alpha now will be a value. It can be 1, 2, 3. So this is how you get the Laplace transformation of alpha t. Thank you so much. Thank you. Thank you very much. I want you to subscribe to my YouTube channel. And as you subscribe, I will appreciate that. Have a nice day.